All right, so this is preliminary before example 5, which is right here. We're going to take a look at a couple things here to understand how radians work in the angular ordered or angular coordinate plane here. So we already know that 0 degrees is here, 90 degrees is straight up, 180 degrees is straight left, 270 straight down, and 360 straight right again, right? So we learned that, and we dealt with that quite a bit yesterday in our homework as well. And we should have seen enough problems that we should be becoming comfortable with that. All right. Every 90 degrees is the next axis. All right. So 0, add 90, add 90, add 90, add 90. If we add 90 again, 450. Add 90 again, 540, 630, 720. You can get it any angle you want. Just keep adding 90 as you go around it. Now, going back to the unit circle, like this has a radius of 1. What's the circumference of this unit circle? 2 times pi times r, and r is radius, which is 1. So the circumference of this unit circle is 2 pi radians. All right? 1 full circle is 2 pi radians. 1 full circle is also 360 degrees. So with that idea that 2 pi is 1 full circle, that's 2 pi radians, and 1 full circle is 360 degrees, that gives us a relationship between radians and degrees, just like there's a relationship between inches and feet. 12 inches equals 1 foot. Between meters and kilometers, 1,000 meters equals 1 kilometer, right? So if you know how much of one equals how much of the other, there's a way to convert from one to the other, to change one to the other. All right, so looking at this picture here, I want to create a radian picture like this. Now, what I want to do, though, is this is a 90-degree jump, this is a 90-degree, right? So if 360 degrees equals 2 pi, if I divide 360 by 4, that'll make 90, right? So if I divide 2 pi by 4, that should be the same amount, right? So 90 degrees is going to equal pi over 2 radians. And I'm just going to RAD. That's typically how radians is abbreviated. All right, so with that in mind, counting by pi over 2's, I'm going to do my radians in red here. 0, if I add pi over 2 to 0, what do I get? If I add 0 to pi over 2, 0 plus pi over 2 equals? 0 plus pi over 2 equals? Pi over 2, thank you. If I add pi over 2 to pi over 2, I'm going to get? Pi over 2 plus pi over 2, adding fractions. We add the tops, leave the common denominator alone. 2 pi over 2. If I add pi over 2 to 2 pi over 2, I get? 1 pi over 2 plus 2 pi over 2. Hard to write this. 2 pi over 2. So 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is? 4 pi over 2. So we're just like we added 90 all the way around, we just keep adding pi over 2's, right? Did you ever see 2 pi over 2 reduces to pi? Yeah. So 2 pi over 2 is just pi. 3 pi over 2 doesn't reduce. Pi over 2 doesn't reduce. 4 pi over 2 reduces to 2 pi, right? And you can see that 2 pi is exactly what it should be if it goes all the way around, right? So 2 pi is the same as 360. Pi over 2 is the same as 90. Pi is the same as 180. 3 pi over 2 is the same as 270. It's two different ways to measure angles, okay? The geometry class, when I went through this today in geometry, they were complaining about why do we need radians? Because that's what freshmen do, they complain about stuff. You guys don't do that because you're sophomores and juniors and senior. You guys don't ever complain about anything, right? But anyway, they were complaining about radians. Radians are so stupid, why do I have to know about radians? But radians is the only way calculus works. Calculus works in radians only, degrees don't work in calculus. Not without a bunch of finagling with stuff and trying to it makes calculus a heck of a lot harder. So radians are very useful in calculus, and that's why we study radians in previous classes before calculus. So when you get to calculus, you can handle the idea of radians, which they aren't that hard to handle. There's just a different way of measuring angles. So, is everybody comfortable with the idea of radians? Because I'm about to weird it up a little bit here. All right, we're all good with this, right?
Yeah, I
All right,
want to.
so I'm just going to erase the degrees off of this picture because that's, the degrees were necessary to understand the radian idea. So I'm erasing the degrees. So, I'm just going to move these so they're kind of prettier here. Now, 30 degrees is pi over 6 radians. You don't have to know this yet. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. All right? Those three angle measures, 30, 45, and 60, live inside 45, 45, 90, and 30, 60, 90 right triangles, right? Those are the types of angles we deal with a lot, right? And again, I'm going to say those again. Pi over 6, pi over 4, pi over 3. Over 6, over 4, over 3. So, if I go back here, and I'm going to doctor this one up last. I'm going to go here first. If I go by pi over 4s, okay, this is 0. Pi over 4, this is 2 pi over 4, right? Pi over 2 times 2 makes 2 pi over 4. Pi is 4 pi over 4. 3 pi over 2, double is going to be 6 pi over 4. 2 pi over 1, double is, oh sorry, quadruple trip is going to be 8 pi over 4. Would everybody agree that these numbers correspond to these numbers? If I just reduce the fractions, that's pi over 2, that's pi, that's 3 pi over 2, that's 2 pi, right? Okay. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So all I'm doing when I'm going by pi over 4s at a time is I'm breaking 1 pi into 4 equal slices. So it looks like this. I got one slice going this way, one slice going straight up, one slice going this way, one slice going straight left. This, of course, is 0, right? And then I also have slices going, if I keep going pi over 4 like that, this pi below is going to be broken into 4 equal slices. So I'm going to slice here in the middle, straight down, here in the middle, and straight right. Each one of those represents pi over 4. So this is pi over 4. This is 2 pi over 4, better known as pi over 2. This is 3 pi over 4, doesn't reduce. This is 4 pi over 4, reduces to pi. This is 5 pi over 4, doesn't reduce. This is 6 pi over 4, reduces to 3 pi over 2. This is 7 pi over 4, doesn't reduce. This is 8 pi over 4, reduces to 2 pi. So I'm breaking it into pi over 4s. There's going to be 8 pi over 4s to make up the entire thing. So we get 1, 2, 3, 4, 5, 6, 7, 8 sections. All right? So if I was told to plot the radian measure 5 pi over 4 in standard form, 0 is this way, 5 pi over 4 is right here, you would simply give me that part of it, put your 5 pi over 4 right there, that'd be standard position. All right, let's look at over 6. So, 0 is 0. If I take pi over 2, if I make it over 6, it's times 3, right? So, times 3, so it's going to be 3 pi over 6 right here. Right? This is pi, so times 6 is going to make 6 pi over 6 here. Times 3 here is going to make 9 pi over 6. Times 6 makes 12 pi over 6. Okay. If I'm looking at pi over 6, I'm going to go pi over 6 at a time. So I'm going to break the pi into 6 equal slices. So 3 slices here, 3 slices there. Right? So it looks like this. Let's go with a different color. Let's go with green. I haven't used green in a while. 0. I want to break this into 3, right? So there's 1, there's 2, there's 3. And I want to break this into 3. So there's 1, there's 2, there's 3. Break this into 3. So I'm just going to extend this further. Extend this further. Oops. There we go. Like that. And then extend this. There we go. 1, 2, 3, 4, 5, 6 on top. 1, 2, 3, 4, 5, 6 on the bottom. We're going up by pi over 6 at a time. So if I do that, my green marker out. 0, this is pi over 6. This is 2 pi over 6, which reduces to pi over 3. This is 3 pi over 6, which is pi over 2. This is 4 pi over 6, reduces to 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 is pi. 7 pi over 6 doesn't reduce. 8 pi over 6 is 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 doesn't reduce. And 12 pi over 6 equals 2 pi. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Just reduce the ones that reduce. All right, there's all our pi over 6s. All right? And then finally, your pi over 3s are involved in that right there. Let me show you. That's too big. Let's go thinner. All right. Pi over 3, so that's 0, right? Here's 0. Then there's pi over 3. There's 2 pi over 3. There's 3 pi over 3. There's 4 pi over 3. There's 5 pi over 3. And then you have 6 pi over 3. So the red ones are all your pi over 3s. So I'll just highlight. So pi over 3, 2 pi over 3. This is 3 pi over 3, better known as pi. 4 pi over 3, 5 pi over 3, 6 pi over 3. Notice that your pi over 3s skip here and here. They don't hit that. The other ones do, right? So pi over 2 gets hit by the pi over 6s, hit by the pi over 4s, but not the pi over 3s. So with that in mind, all that to do this. Sketch an angle to measure 4 pi over 3. Over 3, right? So 1, 2, 3, 4. That's how you do it.
That's it.
That's it. But know that that's it for me because these pictures are implanted in my brain.
Mine's in my brain.
So those pictures need to get implanted in your brains, and you need to be on top of things for this. But again,
You need to print that off and
Yeah, you need
you want to print
that
that
off.
off? It's really pretty. I suppose I can print that off. Okay. Probably should do it in color too, because there's colors and stuff on it.
Yeah. That's
Okay.
the best
All right.
one.
So
Yeah.
there you go.